All right, everybody. So I got some red cabbage here that I just bought from the store, and we put it into the blender. So this is our blender right here. We put I only had half of a head of red cabbage, and you can see I didn't even use all of it. Kind of broke it up into little leaves about the size of what's here. This guy right here, maybe pieces that were a little bit bigger than that. And then put it on the blender and blended it up. Obviously, we added probably about 3 to 4 cups of water to that while we blended it, and you can see that you just get this real dark purple cabbage juice. And so I'll be right back, and I'll show you how to strain this. Okay, so just strain it through a strainer like this, and just into a container that you know you can pour easily out of, or that it will catch it. And you may need to stop and then kind of let it strain through, take the cabbage, dump it in the garbage, and then continue with that again. But just go ahead and strain the whole solution so that you have some cabbage juice. I'd say we've got quite a bit here. You may not need that much, so you can make as much as you feel like you think you'd need. Okay, so here's a few just household products that I've got, plus some chemicals I grabbed from my lab at the school. You can see over here on the left, I've got just some smog balls that have been dissolved in water. This next one here is vinegar, and then baking powder solution. Just take a little bit of baking powder and dissolve it in water. This one right here is sodium hydroxide from the lab, and this one's hydrochloric acid from the lab. This is just some regular household ammonia, and then some fingernail polish remover. We're going to try that one out as well. And then this one right here is just regular water. And so all you're going to do is, if you want to do this at home, you can just take some of the purple cabbage juice, or red cabbage juice, whatever you want to call it, and you just take a little bit and you can pour it into whatever solution it is that you're going to test. And you can see, because water's a neutral pH, it's not going to change a color. But if we come over here to the citric acid one and pour a little bit of indicator into that, you can see that it turns to a pink. And if we come over here to the sodium hydroxide, that one turns like a green color. And I probably poured a little bit too much into that one. You don't need a lot to pour in. So anyways, we'll change some of these up into the colors that they are going to be, and then I'll be right back with the next clip. Okay, so I've mixed them all together, or not all together, but I've mixed them each with some red cabbage juice, this guy over here, and you can see they've all turned some different colors. And so what the colors indicate is they indicate where the solution sits on the pH scale. So something that's very highly acidic, like this hydrochloric acid here, is going to have a pH of about 1. And that's why we see a red color. Red cabbage juice turns red when we're in a pH of a solution, or a solution that has a pH of about 1. Vinegar is about 2 to 3, something like that. So you can see it's not quite red, but still very pink. And then we've got this one over here, which is the smog balls. Now, if you look on the ingredients of smog balls, it's just a whole bunch of citric acid, kind of like lemon juice. You'd probably get a very similar result to that with lemon juice. And so this would be a pH of probably about 3, maybe 3.5, 4, something like that. And then around 5, 6, 7, 8, we get sort of this purplish looking color. This is neutral. The probably pH of 5 or 6 would be definitely not purple, but closer to sort of this purplish pinkish range. So think of a color that might sit somewhere in there, maybe a light purple. And then as we're moving on into substances that are a little bit more on the other side of the scale. Remember, we talked about the pH scale. pH of 7 is neutral. So everything on this side is going to be acid or acidic. and everything on this side is going to be basic. So this one right here is a baking soda solution. And so baking soda solution is in fact a base, and so this kind of gives us this blue color, and you can see how these colors of the rainbow sort of are transitioning across as we go around. Now this next one here, ammonia, is probably about a pH of 10 or so. And then we've got our last one, which is our strongest base that we've tested here in our house, which is a green. And you can see actually this green is almost a yellow. You can see a tinge of yellow in there. This is a pretty low concentrated solution of sodium hydroxide. And so while its pH is probably still around 11, maybe 12, somewhere around there, it's close enough to the end of the side of 14 on the scale where we should get a yellow color if this was a little bit more concentrated. So you may not have something in your house that has a pH of 14. If you do, that would be something that I would very cautiously advise you to probably not use unless you're under like direct supervision with your parents. And I wouldn't do this lab at home unless your parents were helping you for sure at all. So anyways, this, you can see how the color range goes from sort of this red all the way over to this green. And if we had another one that was a little bit stronger, we would have one over here that was yellow. This one right here, the acetone, this is just nail polish remover. You can see that it's purple as well. It's a little less purple than just the water, which is this one. And so this one's probably got a pH of about 5 or 6 sitting in kind of right there. And so there's the color scheme, guys. Hopefully that gives you a visual of kind of what that looks like. And hope you have fun doing this. Again, make sure that if you're doing this at home, that you're not doing this without the supervision of your parents. Okay, thanks for watching.